Great news. The old Thrivemeister's been at it again. Yes, he's been attempting to science. A couple of months ago, Thrivey tried to do an experiment to show the moon emits cold light, and, as one might expect, he made complete balls of it. Imagine my delight to see that he's done it again. And guess what? That's right, he's made another complete balls of it. He was completely unable to acknowledge the mistakes he made last time, and made them all over again. Worse than that, after showing that there was no temperature difference, he decided to change the experiment to ensure that he gets results to support his ludicrous hypothesis. One good thing he did is, unlike his last attempt at science, this time he posted the results, which I plan to go over in detail. With that little preamble out of the way, let's watch Thrivey make an ass of himself. First, let's look at Thrivey's experimental setup. Out of fairness, I'll first look at what he did right.
Now, the platform we used was a piece of insulation which would even block heat from the sun coming from one side to the other, and it was attached to a tripod. The thermometers themselves were about 6 feet 3 inches high off the ground. I'm showing the tip of the thermometer here downward. They were not, they were right side up. And what we did was one side faced the moonlight, one side faced the shade on the moonlight test.
I can accept that as long as he keeps the board vertical.
And then as the moon started to rise in the sky, we would tilt one side.
Go!
Okay, this can be salvaged if he's using the correct type of thermometer.
This is the thermometer that was used, actually 2 thermometers. It's called a Protomax MS6508 digital thermometer, humidity meter, digital psychrometer, thermometer, hydrometer, humidity monitor with temperature gauge, humidity meter with dew point and wet bulb temperature. All we were interested in is what's called the dry bulb temperature, or the regular temperature of the air.
Go!
Well, maybe we can still work with this. He'll measure the temperature of the air directly in front of the board, and at least that'll be close to a useful temperature. As long as he doesn't do something stupid like tamper with the thermometer.
And what we found out is, fantastic, we can remove the cap and get the sensor to be exposed to the moonlight directly.
Go!
Oh geez, what a completely unsalvageable mess. Thrivey, as a former university lab instructor, I can tell you with absolute certainty that a complete understanding of how the equipment works is vital to any experiment. If you're using the wrong equipment, you will get invalid results. First, let's look at the thermometer. It's designed to measure the ambient air temperature. How does it do this? Since you decided to take the plastic cap off of it, have a look at the sensor. This sensor measures the infrared light hitting it and, from this, determines the temperature of the infrared sources in front of it. If the plastic cap is on, the plastic will equalize with the ambient air temperature, and the sensor will measure the temperature of the cap. If you take the cap off, it will just give an average temperature of everything in front of it. It isn't particularly directional, so this would include the ground, the sky, the moon, and anyone standing in front of it. That said, what impact would the moon have on the temperature reading? Let's do a quick calculation to get a rough approximation of this. Since I don't have full specifications of the sensor or know the ambient atmospheric conditions, I'll need to make a couple of assumptions and estimates. The main assumption that I'll make is the sensor detects infrared within an imaginary cone extending about 60 degrees from the center line. The exact number isn't too important for reasons that you'll see later. Next, to give as much chance as possible to measure a temperature difference, I will say the temperature of the moon is at absolute 0. Finally, for simplicity, I'll assume the ambient temperature of the surrounding air is 300 degrees Kelvin, or approximately 17 degrees Celsius. So, you have a cone that extends 60 degrees from the center line. This gives the base of this cone a radius of r equals d tan 60, where d is some arbitrary distance from the sensor. Using the equation for the area of a circle, this means the total area of the base of this cone is a total equals pi r squared, or a total equals pi d squared tan squared 60. Similarly, since the moon has a diameter of 0.5 degrees, or a radius of 0.25 degrees, the area of the moon on the base of this cone is pi d squared tan squared 0.25. Dividing these, we see the area of the moon is less than 1/150,000th of the total area. In other words, the impact of the moon on the temperature reading will be less than 1/150,000th of the overall temperature. Since I assumed the ambient air temperature was 300 Kelvin and the moon was 0 Kelvin, a rough calculation would give the measured temperature less than 0.002 degrees lower than if the moon had no impact. This is far lower than the sensitivity of your thermometers. Just for shits and giggles, let's say the sensor is more directional than I'd estimated, and the cone only spreads an angle of 10 degrees. In this case, the moon would affect the temperature reading by about 0.2 degrees. This is barely within the sensitivity of the thermometer and, for reasons I'll get into later, is within experimental error. Okay, so we've established that the thermometers you're using are not suited to the task. What about your idea of tilting the board? This is simple. The ground heats up during the day and irradiates that heat at night. In other words, the ground is a heat source. While the board is horizontal, that heat source will have the same impact on both thermometers. If, however, the board is tilted, the ground will cover more of the area that the sensor covers and as a result will show a higher temperature. If you want to make more accurate measurements, you have two options. One, you can use a laser thermometer to take the temperature of the board rather than everything in front of it. Or two, you can turn the thermometer that you're using around so that the sensor is facing the board. I know you have a laser thermometer. I've seen you use it. I also know that you didn't want to use it because in your previous experiment, link in the description, you used it and it showed no temperature difference. Turning the thermometer around to face the board might be a little inconvenient, but since you've discovered the hold feature in your thermometer, you should be able to do this. Anyway, apart from his main experiment, Thrivey does a couple of little side experiments, but they're useless, so I won't even bother discussing them. Now that we've seen what Thrivey's attempting to do, let's watch him attempt to do it.
Here's our setup, same as before, same height, everything. We are at, let's see, 80 inches on the the top of the thermometer itself. Way up there, that's the actual sensor.
See, I wasn't kidding. He pissed around with the thermometer and hoped to get useful results.
And there's Mike with a laser.
See, he has a laser thermometer. There's no good reason not to use it, other than the results won't agree with his hypothesis.
So I hit hold, 67.1. I'm going to unhold it, and the light will turn off on its own. Now the other side, I'm just going to sneak around, hit hold before I even look at it. And it is 67.1. Do we have both the 67.1? Is that right?
Well, what do you know? They're the same. Let's look at his next measurement.
I'm going to walk up. I'm going to hit hold. This is 66.9. Oh, why didn't it hold? Now it's held.
Did you see that? The thermometer jumped by 0.2 degrees, not just 0.1 like you would expect from a random temperature fluctuation. What that tells me is the sensitivity is probably 0.1 degrees Celsius or 0.18 degrees Fahrenheit. That's not too surprising because typically a thermometer will measure temperatures in Celsius, the international standard, and convert to Fahrenheit. What this means is that all temperature readings must be taken as plus or minus 0.18 degrees. More on that later.
All right, we'll go with 67.1. I think I made it go up just a little bit. And then let's hold this side. 66.9.
Did you hear that pause? He's trying to figure out why the moon side is warmer. That contradicts his worldview. At this point he tilts the board so it's pointing to the sky. What he neglects to realize is that it also means that the other thermometer is pointing to the ground, a heat source. I had actually joined his live stream by this time and suggested that he tilt the board the other way to take a control measurement, but he ignored me. I guess he just wants to take measurements that support his hypothesis. He needs to suppress any measurements that contradict it. You know, like science doesn't. Before I look at Thrivey's results in detail, I want to give a brief lesson in the calculation of experimental error. The first thing to understand is that when taking a measurement, your value is always plus or minus the sensitivity of the measuring device. For example, if you're measuring the length of something and the minimum gradient of the ruler is 1 millimeter, your measurements are all plus or minus 1 millimeter. You cannot say, well, it's kind of between 126 and 127, so I'll say 126.5. That's not acceptable. Pick one or the other, and it's plus or minus 1 millimeter. Technically, in this case, it would be plus or minus 2 millimeters because there's a 1 millimeter precision on each side of the fish. In the case of Thrive's thermometers, the readings on all thermometers are plus or minus 0.18 degrees Fahrenheit. Next, if you're doing simple addition or subtraction of measurements, the results of your calculation will be plus or minus the sum of the individual errors. For example, if I'm taking the difference between the temperatures of two of Thrive's thermometers, I would add the two errors of 0.18 degrees and call the difference plus or minus 0.36 degrees. That said, taking the experimental error when measuring the difference of the two thermometers is the sum of the uncertainties of the individual thermometers plus the uncertainty of the calibration measurement, which itself is 0.36 degrees. This means that when taking the temperature difference, the total uncertainty is 0.72 degrees. Thrive could have reduced this by using a single laser thermometer to measure the board on both sides. This would have eliminated the uncertainty in the calibration measurement. He had one, but for some weird reason, he chose not to use it. Actually, I think I know the reason for this. In his previous attempt at this experiment, he did use the laser thermometer. It showed no temperature difference, and since this didn't agree with his preconceived belief of what the outcome should have been, he chose to discard those measurements. Anyway, I shouldn't dwell on the measurements he didn't take. The ones he did take are bad enough. First, he talks about how he did the experiment on a night when there was no moon. He demonstrates quite clearly that tilting the board causes the temperature on the thermometer pointing at the sky to be lower than the temperature on the thermometer pointing to the ground. This is expected. You tilt the board, the thermometer facing the ground will show a higher temperature than the one facing away from it. He makes a pretty Excel spreadsheet and graph, but other than verifying that, as expected, tilting the board makes a difference, this really wasn't a particularly informative experiment. Finally, we come to the results of his main experiment. The first thing we see is that Thrive ignored his first measurement, the one where both thermometers have the same temperature. To his credit, though, he shows the next temperature reading where the thermometer facing the moon actually had the higher temperature. Apart from that, he only shows the measurements from when the board was tilted, and he was basically comparing apples and oranges. He notes that the temperature difference between the side facing the ground and the side facing the sky is greater than it was during the test when the moon wasn't visible. The answer to this is simply, so what? Different weather conditions gave a different result. Why would this be indicative of anything? As I mentioned earlier, during the live stream he ignored my suggestion to tilt the board the other way so that he would be comparing apples with apples. Ultimately, it doesn't matter though. All Thrive is really doing is measuring the temperature of the sky and the temperature of the ground. Is there any surprise that these are different? Next, Thrive presents the results of his experiment. I'm sure it comes as a surprise to no one that he thinks he confirms his hypothesis. Rather than just take Thrive's word for it, let's have a closer look at these results. Despite the uselessness of the measurements, for completeness, I've recreated Thrive's results with appropriate experimental errors included. Since, with an experimental error, the thermometers showed no temperature difference, I'm not going to concern myself with whether thermometer A or B was pointing at the sky and just consider the measurements of the sky versus the temperature of the measurements of the ground. Since the calibration measurements have an experimental error of 0.36, I will need to include this in my calculations. In the data, the first two measurements, in orange, are with the board vertical, the remaining measurements, in blue, are with the board tilted. The first thing we see is that, as expected, the temperature of the ground is higher than the temperature of the sky. Also, with an experimental error, the temperature difference remains constant. Next, if we look at the actual temperatures rather than the temperature difference, we see that, when the board is tilted, the measurement from the thermometer pointing to the ground increases by 0.5 degrees. This is more than the experimental error of 0.36, and is expected because, when the board is tilted, the ground fills a greater proportion of the thermometer's field of view than when the board is vertical. Near the end of his video, Thrive talks about an updated version of his apparatus that he plans to use for his next experiment. Let's hear him describe it.
what I'm going to do is I'm going to put a board on the bottom with notches in it. And this will be attached. And this up and down, this vertical, will never change. However, the thermometers will no longer be on this piece of insulation in the middle anymore. They will be, and excuse my poor drawing here, but as we need to tilt one side up to the moon, let's say however many degrees, let's say we do it in 10-degree increments, the other side will be adjusted also.
This is definitely an improvement, although if he continues using the same thermometers, he'll continue getting meaningless results. Even if the moon had an effect on the temperature, those thermometers, for reasons I explained earlier, wouldn't be sensitive enough to detect it. At least this time he'll be comparing apples with apples. Thrivey, if you want to get valid results, use your laser thermometer to get the temperature of the boards. The thermometers you're using just get the temperature of the sky. To be fair, at least Thrivey does the experiments. I must give him credit for that. He does them badly, but he does them. That's a lot more than I can say for idiots like Fuckwit Word or the Nathans or Leaky Warrior or that crowd of morons. Should I do the experiment? No need. Greater Sapien already did it. Link in the description. He used what I consider an acceptable experimental setup, and he showed no temperature difference. Will I do the experiment? I've ordered a fairly good laser thermometer from Amazon, so given the current environment of social distancing, I should be able to find some time to do the experiment. I'm not going to make any promises, though. Lately, the Venn diagram of suitable weather conditions and full moon can best be described as two non-intersecting circles. Anyway, I'm looking forward to Thrivey's next attempt at science. One of these days he might get it right. Until then, in the words of British comedian Sarah Millican,
wash your fucking hands, stay in the fucking house.